Hello everyone, this is EasyEDU and in our today's video lecture we will derive equations of motion by using the simplest possible method. Before deriving the equation of motion, I hope you all know about displacement, velocity and acceleration, as displacement is the shortest distance between two points and is denoted by del S is equal to SF minus SI, where the SF is a final position and SI is the initial position. Similarly, velocity is the time rate of change of displacement and is equal to V is equal to del S divided by del T or T. Similarly, acceleration is the time rate of change of velocity and is equal to del V divided by T. All of these are vector quantities. Now, the first equation of motion is Vf is equal to Vi plus At. Similarly, this is the second equation of motion and this is the third equation of motion. We will derive all of these equations by using the simplest possible method. Let's begin from equation number 1. The first equation of motion. We know that acceleration is given as A is equal to del V divided by T, where the del V is change in the velocity and is equal to Vf minus Vi. You can denote this Vf and Vi from anything like V0 and V. Here I have denoted this final velocity by Vf and the initial velocity by Vi. So acceleration is equal to Vf minus Vi divided by T. Now multiply both sides by T. The equation becomes At is equal to Vf minus Vi. Now we have a new equation, At is equal to Vf minus Vi. Now when we shift this minus Vi to the left side, we will get Vf is equal to Vi plus At and we can write it as Vf is equal to Vi plus At, and this is the first equation of motion. Now we are proceeding toward the second equation of motion. There are two methods for second equation of motion. The first one is the simplest, which I will use is a graphical method, and similarly the second one is the Merton rules. According to Merton rules, V is equal to Vi plus A plus Vf divided by 2. We directly derive this equation, but here in graphical representation you will understand what we are going to do. The second equation of motion is S is equal to Vit plus 1 over 2At square, where S is the displacement, Vi is the initial velocity, T is the time, A is the acceleration and T is again the time. We will determine the value for S is equal to Vit plus 1 over 2At square using this graphical method. Now let's suppose a car is moving on a road with a constant velocity and suddenly it accelerates its car. With constant acceleration, the velocity of the car changes from Vi to Vf during the time from t0 to t. So this is actually a Vt graph, velocity time graph. This is the x-axis which determines the time and this is the y-axis which determines the velocity. And we know that displacement is equal to area under the Vt curve. Here the velocity time curve is this and this. Area under this curve is equal to the displacement. Now we have a geometry. This is a geometrical shape and this geometry is known as trapezium. So the distance covered will be equal to S is equal to area of trapezium. Area of the trapezium is given as 1 over 2 into A plus B. This is the A side, this is the B side and this is the C side, which is the base actually here, divide into 1 over 2. Similarly, we have a geometry. This is the Vi, this is the Vf, the final velocity after some time, and this is the time axis t. So using this equation, we will get the area under the curve as S is equal to 1 over 2 into Vi plus Vf. This is Vf, which is the A, and this is Vf. Now using this formula, we have A is equal to Vi plus B is equal to Vf, and C is equal to the time axis, which is this one. We will get S is equal to 1 over 2 Vi plus Vf into t. Now we will eliminate this Vf term from this equation, and we know that according to first equation of motion, Vf is equal to Vi plus At, or final velocity equal to initial velocity plus acceleration and time. So putting the value for Vf, we will get S is equal to 1 over 2 into Vi plus At into t. Now this Vi term will add with this Vi term, and we will get 2 Vi. S is equal to 1 over 2 into 2 Vi plus At into this t. Now we will multiply this 2 and 1 over 2 first with this term and then with this term. By multiplying t with this 2 Vi, we will get 2 Vi multiplied by t and dividing by this 2 plus At multiplied by this t and divided by this 2. We will get S is equal to Vit plus 1 over 2 At square, and this is the second equation of motion. Now keep this equation number A in mind. We will use this equation to derive the third equation of motion. Now we know that S is equal to 1 over 2 Vi plus Vf into t. This is the equation number A, which we have derived in the previous slide. We will just eliminate the t from this equation. By eliminating t, we know that A is equal to acceleration is equal to change in velocity divided by time. By multiplying both sides with t, this t will cancel with this one, and we will get t is equal to Vf minus Vi divided by A. Now we have this equation, t is equal to 1 over A into Vf minus Vi. We will put this value for t in equation number A. So S is equal to 1 over 2 into Vf plus Vi into 1 over A into Vf minus Vi. This is the value of t which we have substituted in this equation number A, and we have this equation now. Now the equation is pretty simple. We know that S is equal to this 2 will multiply with this A. We will get S is equal to 1 over 2A into Vf plus Vi into Vf minus Vi. Now 2as, multiply both sides by 2a. This 2a will cancel with this one, and 2as will become equal to Vf plus Vi into Vf minus Vi. Now we have a formula which is a plus b into a minus b equal to a square minus b square. Similarly, we have this equation Vf plus Vi into Vf minus Vi. We use this formula to get the new equation, which is 2as is equal to Vf square minus Vi square, and this is the third equation of motion. Thank you for watching. Don't forget to subscribe Easy Edu for more videos.